Hello everyone, I am Dr. Tanmay Vishwas. I welcome you all in my channel Tanmay Chem. Today's topic of discussion is the easy MCQ. That's why I request everyone to try this question and write your answer in the comment box. I believe you have tried, so let's start. Now look at this molecule. It is actually aromatic acid amide. So when we say aromatic acid, when this benzene ring is attached to this carboxylic acid group, so that time we say it's an aromatic acid. And if these aromatic acid forms a amide with, obviously it is also aromatic amine, so this is actually aromatic acid amine, where the amine part is aromatic, acid part is also aromatic. And in this case, if you look at here, bromine reacts with FeBr3. So these reaction, if you look at FeBr3, by the way, Fe3 plus is actually a Lewis acid, means it has vacant orbital which can accept a pair of electron, or more specifically if I say it's an electron deficient molecule. So what happened, it reacts with bromine. We know bromine is actually a halogen, means it has three lone pair in outermost shell of this molecule. So what it does, so these one of this lone pair is given to iron. By the way, instead of this I am writing FeBr3. So what happened, bromine donated its electron density, so here bromine is acting as Lewis base. So combination of this Lewis base, Lewis acid, it results in a addact formation. And these addact, you can see this bromine is carrying a formal positive charge. Why? Because this bromine gave its pair of electron to this. So consequently, iron bromide got some extra electron. So that's why it got a formal negative charge, and bromine, since it gave electron, so it got a formal positive charge. Now this is the addact. But look at bromine, electronegative atom carrying a positive charge is not that much stable. So consequently, this will break down this way. What it will result, this addact breakdown, and it will produce Br plus and FeBr 4 minus. Okay, so these complexes produce. So actually this is the role of FeBr3, which generate this Br plus, and these Br plus actually act student as electrophile, such that aromatic electrophilic substitution can take place. So we have generated electrophile. Now question, what is the regioselectivity, at which position this reaction will take place? Now if you look at, there are 6 probable position available, 1 2 3. So ortho, meta, para for this benzene ring attached to this double bond O. And another thing, 1 prime, 2 prime, 3 prime, you can say. By the way, this is not a nomenclature, this is actually another ortho, this is also meta, this is also para, do not get confused. Now where 6 position possible. So if you want to get the right answer, you need to understand the basic concept like electron richness. Which position, this 1 2 3 or ortho, meta, this all this reaction, which one is maximum electron rich, such that aromatic electrophilic substitution can take place. From this thing you can understand this electrophile is actually a electron deficient molecule. So where it will preferentially react, obviously the place which is more electron rich. Now if you look at this benzene ring, ring number 1, it is attached to a carbonyl group, electron withdrawing group. So obviously you can say this benzene ring is electron deficient. Okay, in the other hand, if you look at this ring is attached to NH, and this nitrogen has a lone pair. Now I agree with this statement that okay sir, these lone pair can have a resonance with this, so lone pairs availability is less, agree. But along with that, another possibility also there, that it will come, it will open. So I can draw one canonical form, means the negative charge will come this ortho position, this is NH carrying a form positive charge, and this is C double bond O, this side PH. Rest of the bonds are as it is. Again, if you want to draw another canonical form, you can see this will come here, it will go there. So what is the conclusion? That because of this nitrogen lone pair, the 2 ortho position and 1 para position is relatively electron rich. This much. Now if these positions are relatively electron rich, so we can say aromatic electrophilic substitution will take place either ortho or para, one of them. But question, how can I decide where this reaction will take place? Because both have same probability, electrophile, electron deficient molecule, and these ortho and para are relatively electron rich because of the plus R effect provided by this nitrogen lone pair. Fine, this is done. Now there is another story. Now look at, this is your benzene ring. Okay, now this side it is NHCOPH. By the way, NHCOPH is actually a big group, and here you can expect that, sir, CN rotation, it's a single bond, so that rotation also possible. Consequently, these hydrogen will face the steric effect because of this. Not only this, these hydrogen will also affect the steric effect or bulk effect because of this molecule. Now what will happen? Because of this Br plus cannot go closer to these two ortho position, means these two ortho positions are not accessible for this Br plus because of the bulkness exerted by this COPH group. So what option left? Only para. So aromatic electrophilic substitution will take place, and these Br will go to this para position. These will be our product. So you understand where the reaction will take place. First these ring cancel because of the electron withdrawing effect of this carbonyl group. So this is electron deficient. Aromatic electrophilic substitution doesn't prefer electron deficient ring rather than electron rich ring, which is this ring, and here para position because ortho positions are sterically crowded due to this COPH ring. So this is the overall discussion. Now what is the product? Based on the mechanistic discussion, option C is the product. Now in your exam hall, if you think, sir, I do not have that much time to draw mechanism, how can I get this? Yes, remember bromine with Lewis acid like FeBr3, AlCl3, etc. that generates the electrophile. So it's aromatic electrophilic substitution, and these ring number 1 attached to electron withdrawing group, ring number 2 attached to electron donating nitrogen atom. Consequently 2 is more rich. Fine. So if you think 2 is more rich, then obviously option A and option B is gone. Okay, so this is called process of elimination, very helpful for solving MCQ in short time. This is gone. Now competition is actually Br versus Br. By the way, did I mention ortho? We know this nitrogen donated its lone pair at ortho and para position, not meta. So same logic, it is gone. You don't need to have any confusion regarding where this is, what is the bulk effect. But I have discussed everything such that you will learn everything, but it will not. So only this option left. So this is the answer. Agree? And you need to do this thing very fast, and that's why you need to learn more. You need to watch more videos, explanation, or you need to practice more questions. Then only you will be able to do it faster. And another suggestion, please draw all the structure I have written in this slide by yourself on a pen and paper. It will help you to remember it better. Now this is the overall discussion. I believe this video may be useful. Please write your opinion in the comment box, and if you really consider the content of my channel is worthy, then please help this channel to grow. By the way, if you have any doubt regarding the logo of my channel, I request you to read about this. I never support any kind of brutality. So thanks for watching. See you in my next video. Bye bye.